All right, good morning or afternoon or evening. Um, I'm wearing my glasses today and they have this anti-blue light in them, and so sometimes, depending on the way I'm tilting my head or something, it'll have like this weird purple light in the camera, so it's very sci-fi like. Sorry. So here's our little Lin-Manuel Miranda prompt for today. Good morning. Grateful for the very notion of you, even more grateful for the reality. Look at you, a dream realized. We're off. Let's go. There's no picture that goes with this one. Right. I hope you guys are having an okay morning. It's Thursday, so one more day of this stuff. I hope your other classes have been going okay as well. This class has been doing pretty good. More and more people are answering and doing their work. I think y'all are getting the hang of things. I got way less panicked questions yesterday compared to the day before, so. Okay. Today is March 26th. There weren't as many days for me to choose from, so I put almost all of them up today. First is Live Long and Prosper Day. If you don't know what that is, it's from Star Trek. It's a phrase that Spock, I guess, and his people, the Vulcans, right, say, like, live long and prosper. Don't know what to do with my thumb. Live long and prosper day. I guess it's a day for you to say this to people. It's Make Up Your Own Holiday Day, because we don't have enough holidays, apparently, so if you can think of a cool one, maybe comment and let me know. I'm kind of curious about if you could invent a holiday, although at this point I feel like almost everything has its day, so. It's National Nougat Day. Nougat is that, like, squishy, really sweet stuff that's inside of a Snickers bar. That's the only time I ever eat nougat. It's just too sweet for me. And it's Spinach Day. That one I like. I do like spinach. Fresh spinach. A lot of Americans eat it as creamed spinach, which I think is disgusting. And that's probably why a lot of people think they hate spinach, and that's just because you were eating it wrong. All right, so today, I will go over yesterday's assignment. I'm going to go over, like, who got the questions wrong or whatever, and then I had a request from Rosie specifically to go over the last couple, the actual solving part, and those did seem like they were a little bit confusing for some people, so I'll make sure I do that. I've also uploaded cheat sheet notes into the classwork section, because some of you didn't, a lot of you, I guess, didn't bring your notebooks or anything home. And yeah, I mean, you can Google this stuff, clearly, since all of you were able to do that volume problem without a formula sheet. But I thought it'd be nice to put it all in one place, so I'm going to put that into the classwork materials section, so that on a warm-up or something, when you get to something you don't remember how to do exactly, you can look through those notes. There's also an assignment on equations for today. Some of the problems do involve distributive property. Instead of doing a Google form this time, it involves playing games instead. I mean, even in class, I don't just want to do worksheets all day, every day, so I was trying to think of some different things that we could do, and this is one of them. So we've got a game instead, and tomorrow we'll probably do a quizzes. So when you go to the assignment, there'll be a link. You click the link, and it'll ask you to create an account. If you already have an account from another class or something, you can use that. But if not, you can create an account using your school Google account. So don't type in everything. You can be like, sign up using Google account, and you'll use your school Google account. And then when it asks you for the teacher code, it's Win40. Okay, and then that'll let you access the playlist for today. Note. Somebody asked me, Chris, asked how we're supposed to do this work without a calculator. Well, you can get a calculator on your phone. Fun fact about if you have an iPhone, I guess. I don't know if you have an Android, I can't help you. But the iPhone calculator, it doesn't seem like it has a lot of functions, but if you tilt it to the side like this, all of these come up, which can kind of help. I don't like this one because it's not quite the same. So as like the graphing calculators or whatever. So I actually use this app called Calculator Plus, which is free. I think you have to pay if you want more themes and stuff, but it should be free. And then it has a lot more functions in it, and it lets you type stuff in. So you can type in, like, 5 plus 11 divided by 10, and it comes up like this instead of doing it like one step at a time. So I actually used to use this at school a lot when I was making my answer keys and things, so I use this one almost as much as the graphing calculators at school. So there's that. You can also Google calculators and something online will come up as well, so don't make this excuse. Okay, so now that that is out of the way, let's look at the numbers. Let's look at everything for the assignment from yesterday. Most people got number 1 right. Woohoo, good job. Number 2 too. And number 3, and number 4. So it seems like the warm-up went pretty okay. And then 4 and 5 were the two just expanding using the distributive property problems, and more people got them right. Especially number 5 is almost exactly the same as a problem from the assignment the day before, but way more people got it right this time. So either you understand it better after seeing the answer, or I explained it well, or something. The bonus, not that many people got this one right, but that's why it's a bonus question. It's pretty much exactly the same as the example I gave in the video. I just switched the order around. So if you expand it out, you should get 5a minus ax plus 5b minus bx. Now, some of you, for whatever reason, rearranged the numbers or the terms, and that's fine. The main thing is that those terms are there. So, like, for example, ax has to be minus ax, bx has to be minus bx. As long as those two are negative, it doesn't actually matter what order you go in. So a couple of you put, like, 5b minus ax plus 5a minus bx, or some stuff like that, weird stuff. Like, you change the order. I'm not sure why you did that, because that's not the way I taught you how to do it. So that was weird, and makes me think that you might have looked it up somewhere. So I'm not going to give points for that because you didn't solve it the way that I taught you to do it, and it's bonus. But that is technically correct. Most people did get number 6. A few of you did not follow the instructions I wrote. The instructions very clearly said just put the number as the answer. Do not put x equals or anything, because I got tired of typing all the different types of answers that could come up. Like, some people put capital X, lowercase x, there's a space between the equal sign. There's not a space, and I got tired of it, so I just wanted the answer, and I put that in the instructions. But some of you don't like to read instructions, so that's why you missed it, and I'm not giving you points for that because you didn't follow the instructions. Same as the above. For number 7, there were a lot of really weird guesses. Don't know why you do that. Number 8, same thing. Most people got it. Some people didn't follow instructions. Some people guessed really weird. About 80% got number 9 right, and that's taking into account the tries. So if I took out all of the previous tries before try number 3, that should be a higher number, I think. But yeah, most people actually got this one, which is good. And then number 10, most people got it. Like 75% of the people got this one right. But then a lot of people, like 11 people, put the same wrong answer of 0.4. Why? I'm not sure. I think you might have put the X in the wrong place. Very early on, I missed a per month, and so it wasn't super clear where you were supposed to put the X for the Gym B. Luckily, Christian messaged me about it, and I fixed it after that. So I don't think it affected that many people, since he was the only one that asked me about it, which is a little bit alarming. But I did fix it, so it was fixed pretty early on, so most of you, it probably didn't affect you at all. All right, so at this point, I'm going to go ahead and go over a couple of the problems from this assignment, some of the later ones, just so we can see how those were done and be on the same page, especially going into the problems today. All right, so I wanted to specifically go over number 8 because I think some people got a little confused. So I'm going to deal with that one first. So let me first write this one out. So it's negative 8.25x plus 12 minus 1.75x equals 10.5x plus 1.75. Right, so that's where we're starting out. So the first step, combine like terms. Okay, so there's no like terms on this side because we have an x and we have a constant. But if we look on the left side of the equal sign, this has an x and this has an x. So take these, combine those together. It's negative 8.25 minus 1.75x, because remember the sign is very important there. So if we take, it's almost like adding them, but they both stay but it stays negative, you know what I mean? Because if you subtract this from something that's already negative, it just becomes more negative, right? So if you subtract 0.75, this turns into negative 9, and then if you subtract another 1, it becomes negative 10. So you've got negative 10x plus 12 equals 10.5x plus 1.75. That's where we're at. Okay, nothing else to combine, we're good to go. Step 2 is we want to gather our variables together. So our variables, here's x, here's x. Remember, we want to add the bigger numbers and subtract the smaller numbers. In this case, if you add this 10x, this is negative. If you add this to the other side, then everything stays positive. So that's kind of the way we want to go, I think. So if we add 10x, I forgot to draw the line. Add 10x to both sides. Okay, that goes away, that becomes 0. So we're left with 12 on the left. 10.5x plus 10x is 20.5x plus 1.75 left on the side. Okay, next step is we want to gather our constants, our numbers together. 12 is already by itself, so we don't want to move that, but we can subtract 1.75 from both sides. So that becomes 0. 12 minus 1 is 11. 11 minus 0.75 becomes 10.25. 10.25 equals, we're left with 20.5x here on the right. Last step is always to divide. We want to divide by the coefficient. Because that's what we're trying to get it rid of, because we want x to be by itself. So we're getting rid of this coefficient, 20.5. So in order to do that, we divide both sides by 20.5. This turns into 1, so we're left with x on the right. 10.25 divided by 20.5 is 1/2. Or rather, 10.25 is half of 20.5, so it's 1/2. Or some of you put 0.5, that's fine too, right? So that was how, oops, yeah, it should be 0.5 or 1/2. Okay, there we go. I'm having some issues with my tripod, oh crap. Having some issues with my tripod today. Okay. Oh, hey. That's better. Should have just done that to begin with. Okay. The next one I wanted to look at was number 9. So number 9 says Gym A charges a registration fee of $75 plus $35.75 per month for members. Okay, remember that when we are dealing with these word problems, we're looking for that word per, because that is a key word telling us to multiply. Like if you went to the store and you paid $10 per apple, well, that's crazy. Then however many apples you bought, you multiply that by $10, right? Or if you get paid $12 per hour, then that means every hour you work, you multiply it by 12. So per means multiply. Each also means multiply, right? Let's take that. So that means that whole thing for Gym A, 75 75 plus 35.75 multiply, right? And in these equations, when we're multiplying, that means x, because when you have a coefficient next to x, that means these two things are being multiplied together. So if there's something being multiplied, it's just x. So anytime you see a per, that's just telling you, this is where x goes. Okay. Gym B charges a registration fee of $164 plus $17.95 per month for members. After how many months would the total cost at Gym A and B be the same? The same. That means equal sign. Oh, the grammar is really bad. After how many months would the total cost to be the same? Oops. All right, anyway, so an equal sign goes there. Now you're ready. We're ready to get going. Okay. Step 1, combine like terms. There are no like terms. Step 2, gather our variables together. 17.95 is smaller than 35.75, so let's subtract half. Okay, now we're going to subtract this part. This is a little bit harder for me to do in my head. So anyway, now I'm going to consult my handy dandy calculator. 35.75 minus 17.95. Somewhere Joseph is like, Miss, I got it. I know you got it. All right, anyway, it's 17.8. So we have 75 plus 17.8 equals 164. Right? With me so far? Yes, yes. Okay, so next is we want to gather our constants together. 1.64 is already by itself. We want to leave it alone. If there's no point in moving it over here, because then we just have 0 over here and that doesn't help us in any way. So let's move the 75. This is a positive 75, which means that to move it over to the other side, we need to subtract, because that's the opposite of positive. Or, yeah. So subtract 75 from both sides. Oops, I'm going to circle this. 17.8 is left here. Oh, I forgot the x. Haha. I was about to be very confused. And then 164 minus 75 gives us 89. All right, well, now we are at the last point where we want to divide by the coefficient to get rid of it. Our coefficient is 17.8. All right, so we're going to divide both sides by 17.8. This turns into 1, so we have x. And then 89 divided by 17.8 gives us 5. Okay. I think y'all just get scared off by decimals. It's really not that bad of a problem, I think. I think those were the main things I wanted to go over. The model didn't seem that bad. Well, I guess enough people missed it that I'm a little bit concerned. Let's go ahead and go over number 10 too. Number 10. Oh, there's a picture, so let me see if I can redraw that picture for y'all. Here's our picture, very crudely drawn. And so in order for us to solve it, we have to change this into an equation, right? These are positive x blocks, so 1x, 2x, 3x, 4x. These are -1 blocks, -1, -2, -3, -4. So 4x minus 4 on that side. This is a negative x block, -1. So our equation is 4x minus 4 equals -x minus 1. Now we can solve it. There's no like terms to combine, so we can effectively skip the first step. Gather our x's together. If we move this, we add x to both sides, and the x's stay positive. So let's do that. So plus x, because plus is the opposite of minus. See, because we want this to cancel out to become 0. Once we do that, we have 5x minus 4 on the left, negative 1 on the right. Okay, add 4 to both sides. Negative 1 plus 4 is 3. 5x equals 3. Last step, divide by the coefficient. So divide by 5, divide by 5. So you see that x equals 3/5. And then we want to change that into a decimal, since you could see that all of the answer choices are decimals. Remember that 1/5 is 0.2, so this is really like 3 times 0.2, so that's why you should have gotten that the answer is 0.6, which was the middle. Put more answer choices so it would be harder for y'all to just guess, I guess. All right. Oh, you know what? I lied. I do want to go over one notes per se, because when I was going through the games, I noticed one type of problem that might be confusing for some of y'all. I don't remember what I can't remember exactly what the problem was, but it looked something like this. Okay. What does this say? It says x divided by 2 equals 5. If we want x to be by itself, we need to get rid of the divided by 2. What's the opposite of division? Multiplication. Okay, so that means in order to get rid of this divided by 2, we basically need to multiply both sides by 2. So now this goes away, so we have x equals 10. Okay, I'm not sure if y'all went over that in 7th grade last year, but this one I already anticipated could cause problems. Everything else that I saw in the example problems in the game should be fine. But this is one that I thought might be a little nice to go over. All right, so that's it for that. Back to the other video. Okay, so good job getting through all of that. I hope that was helpful, right? So good night, or morning, or afternoon, or evening, or whatnot, though I guess for attendance sake, you would be watching this before 4 o'clock, so maybe I should take out the good evening, good night, good afternoon, whatever part. Good night. Grateful for the reality of you, even more grateful for the notion of tomorrow. Rest up, we need you at your best. There's a pair of sneakers, I guess, because hopefully you take off your shoes before you go to sleep, so yeah. All right, thank you for watching today. I hope you guys enjoyed playing the games for today. I do want to try to find more interesting stuff for you guys to do math-wise. So I hope that was a little bit of a different experience today. All right, have a great rest of your day, and I'll see you tomorrow.